This is CPM Calculus Chapter 6, number 93. So we want to find the derivatives, okay? And it says to consider trigonometric substitutions or identities. For example, we know sine squared of theta plus cosine squared of theta equals 1. So use things like this to make your work easier. Okay, so A we have the derivative of 4 times cosine of 2x times sine of 2x. So here we have the product rule. We have two different functions. So if we take the derivative, it's going to be the first times the derivative of the second. Derivative sine of 2x is cosine of 2x times the derivative of 2x. Remember the chain rule, times 2, plus the second times the derivative of the first. That's going to be 4 times negative sine of 2x times 2. Again, the chain rule. So let's go ahead and combine these. We have cosine 2x, 4 and 2. 4 times 2 is 8. Cosine times cosine is cosine squared of 2x. Plus 4 and 2 again is 8 and a negative. So we have negative 8 times sine of 2x, sine squared of 2x. Okay, so here's where our identities help. If we factor out an 8, we get cosine squared of 2x minus sine squared of 2x. Okay, this is not this identity, right? Here we have a plus, here we have a minus. But another identity, we have the double angle identity, if you remember. We have cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta. And that looks like this, okay? So instead of theta, though, we have 2x. So this theta becomes 2x. So 2 theta is going to be 4x. So this is going to be 8 times, and we have cosine of 4x. Now here's what we use to get this. We use this identity right there, the double angle for cosine. All right, let's go on to part B. Part B, here we're trying to find the derivative of 6 cosine squared x plus 6 sine squared x. This one's going to be pretty easy. I'm going to leave it as the derivative form, but I'm going to simplify it first. I'm going to factor to 6, and then we have cosine squared x plus sine squared x. Right? This right here we know is 1. So it's the derivative of 6 times 1. Well, what's the derivative of 6 times 1? That's just the derivative of 6. That's a constant, so we know the derivative is 0. Okay, so again, this one we use the identity cosine squared x plus sine squared x equals to 1. Finally, in part C. Okay, so in part C, we're asked to find the derivative of arc cotangent. We have to remember that the derivative of let's just do it really quickly, of our arc cotangent with respect to x is equal to 1 over 1 plus x squared. Okay, so that's just to help us. So when we do this, remember we're going to be 1 over 1 plus x squared, but x is what's here in parentheses. So it's 2 to the 3x power squared, right? Because this whole quantity here is x. And then we have to use the chain rule, so we're going to multiply by the derivative of 2 to the 3x, and that's an exponential, so it's 2 to the 3x times ln of 2, times, we have the chain rule, we have to multiply by the derivative of 3x, is 3. This is all over 1, so we can simplify this to be, let's put 3 times ln of 3 in the front, times 2 to the 3x power, and put in 1 plus 2. Oh. Here we multiply this, 2 to the 6x. So there we go, and that is the derivative of arc cotangent of 2 to the 3x. That ends for CPM Chapter 6 of Calculus number 93.